Hey everyone, this is experiment number 5 of our computer networking class, ET497. So this is probably one of the most fun projects that you'll do. You'll deal with programming some Arduino modules. Some of them have Ethernet connectors. Some of them have Wi-Fi interfaces. So it's going to be really good. Let me quickly just show you what the kit contains. So the kit contains a few things. First of all, it's got this really neat, it's an Arduino board. Think of it like an Arduino Uno board. And, but it also has a built-in Ethernet jack, right? So that we can easily plug in our Ethernet connections. And it also has, and this is for later on projects, it also has a TF card reader here. So you can put in your little memory stick there, and you can put in photos or MP3 files, and you can play them through a website. So this little guy has the ability for you to program and embed a web server. Okay, so let's start off with this guy here. More clear. So we have a lot of inputs and outputs pins, right? So you'll be able to do things like have a breadboard, right? You'll be able to plug in a LED and a speaker, or you got switches, you got all kinds of things. And then you have the wires where you can connect from the breadboard, right? You'll be able to connect to the board here. And so you'll plug this into a computer. It's got a nice USB cable. You'll do some programming. You'll connect this to the USB computer. You'll download the web server and everything else that you need to. And then you will be plugging this into, for example, right, a switch like this, and you'll connect the other cable to another computer, and you'll be able to access the web pages that you program inside here. And you can have like a button on your web page where you'll be able to click on the button and the speaker will turn on, or you can press the switch and something will come on the website, for example. Those kinds of things. And there's also a Wi-Fi module that you'll have. You also have a power supply for the Arduino board. Okay, so you don't have to use batteries, you can just use this power supply for the Arduino board. So let's check out the instructions. Okay, so we're calling this the Arduino Ethernet Wi-Fi IoT. IoT is Internet of Things, and it's a very popular term used right now. There are billions of devices out there that are wireless devices that are used in Internet of Things, right? Like the Ring camera that you have on your door. There's endless amounts of devices out there that have built-in Wi-Fi and built-in microcontrollers that you can embed a web server. All right, so this is going to be fun. You'll program a web server, and you'll do things like this. So for the report, I would like for you to make sure that you turn in your source code that you wrote, any screenshots of what you see on the websites that you're doing, even your HTML code also, if you do anything else with that, any photos of your project. Okay, so take a photo of take a photo of this, the things that you wired. All right, so these are the main things that I would like for you to do. Turn on a speaker on and off with the button on the web page. Turn the 3-color RGB LED on and off with individual buttons. So you'll have 3 buttons, and when you push one, it'll be like green, red, and blue. And the other one is when you press a switch on the breadboard. So you have a little switch here on the breadboard. So if I press that switch, I want something to come on the web page. And the other one is also turn a servo motor on. So you have this little little servo motor here. This little servo motor. And I want you to turn it on, rotate left or right with it. There's some little horns that you can put in on top of the motor, and that way you can see where it's turning. Okay, and that's about it. So the board that we're using with Ethernet, it's called the Key Studio W5500, and the 5500 is the chipset that they use for their Ethernet connector, and it's a really good board. The first thing you want to do is install the Arduino software. All the software is given in that memory stick, right under the projects folder. Okay. Or you can go and Google Arduino and download the latest and greatest, but you will have the Arduino software in there. You're also welcome to go to the actual website for the board, right? It's an Ethernet development board. Without PoE means without power over Ethernet. There's some modules out there that you can power them through the Ethernet port, but this particular one, you'll need the external power source, and this is why we give you an external adapter to power the board. Okay, so again, the board has some really neat features. It's got an Ethernet port, got the USB connector to program it, power, and that TFT card reader, so you can dump MP3s, text files, whatever you want. Right, so this is the network chip. It's one of the latest network chips that are out there. That's easy to use. Here's some more specs. Here's a couple of examples of code. So when you download this sample code to the board, like in this case, for example, what you're doing is you're saying, hey, board, go ahead and grab an IP address, right? And if it doesn't grab it, go ahead and display this message: failure to configure Ethernet using DHCP, right? So this will just this will work in a network if you're connecting it to your home router, for example. The home router will give it an IP address, but it's probably not what we're gonna do. So we'll be able to, there's a lot of examples, by the way. But here's another example. You will make sure that you install the libraries, and I'll show you how to install the libraries, or otherwise this will not work. So in this case, we're going to assign an IP address, right? So in this case, I want to assign an IP address. So it's got this nice Ethernet configuration here, and we're assigning it an IP address. We're also assigning it a MAC address. Remember how I told you that all the Ethernet cards have their own MAC address? Well, guess what? We can create a MAC address here, right? So we're assigning it whatever MAC address we want over here. And of course, we're using port 80 for the Ethernet server, right? Let me see if I can make this a little bit bigger. You can see it better. All right. And so this one will do that, but this one will also do a few other things. It will say, hey, if you put in a memory card in the slot, right? If you were to put some little memory TFT memory card here, you can actually read the files. So in this case, it says if you don't have anything, it'll say files found, and if you have something, it'll say files found. If there's nothing, it will say fail, right? Volume not found. But if it finds a file, it'll give you a list of the files that you have in there, and then you can actually open them. Right? So there's a little bit more info here, but you can do something like you can test what the IP address is. This is what the website will look like. If it's a text file, when you open it, it'll display what's inside the text file. If it's MP3 files, you can create a folder in that memory card, and you can put music, and when you click on it, click on one of the songs, and it'll start playing through the website. There's a lot of examples. For example, this one, you can configure it to put an LCD screen. Okay. and so on and so on. There's a lot of information here, quite a lot of data. Make sure um, that you look at this, but also I have in here in our folder, I have the Keystone W5500 files, and you have the libraries, and you got those two sample codes. Let's look at how we install libraries in Arduino. So these are the libraries. Inside the libraries, there's a lot of examples. We would be looking at something like Ethernet 55. We can look at examples and look at the kind of things you can do. You can do chat servers, you can do a Twitter account also. You can do the web client or the web server. Okay, so lots of things, right? Lots of examples come inside each one of those libraries. Here's another one, right? A lot of examples on how to read and write to that SD card or TFT card. Okay, and there's an SPI also, and so there's examples on how to read inputs and outputs out of those ports, and this is what we're going to be doing in this lab. Okay, so we're going to be using the SPI examples. So like there's one right there, for example. So all right, installing the libraries. So I would just grab these examples, I'll copy them. If they exist in the folder that I'm going to put them on, I will not overwrite it, okay, because that means that they might be older than what I already have. So I would look for the Arduino folder, the Arduino installation folder. Typically, it will put it on their either programs, files, x86, right? And Arduino libraries. Sometimes it might put it under this one, but I believe it's putting it under the x86 only. So program files, x86, libraries, and I would just right click and I would say paste. Provide administration, yeah, that's fine. Okay, copy this, yeah. And the third folder. Okay. And to test it, to make sure that the libraries actually are working, I'm going to get out of this. I'm going to come over here to the examples. I mean, you can copy and paste them over here, or you can go to the folder and go to the Keystone and just open the example. I'm just going to use the second example here. It's brand new, so it wants to create a folder for it. Yeah, that's fine. Okay. So I'm going to plug in. Okay, so I'm going to go ahead and plug in this to my USB computer. And I don't need any of this stuff. And I also don't need the power yet because I don't have anything connected to the ports over here. All I want to do is plug it into my USB connector. It works like an Arduino Uno. Okay. Plug it in. It works like an Arduino Uno, so if you look here, board Arduino Uno, that's perfect. Make sure that you select the COM port. Okay, in this case it's using COM port 3. I had already plugged it in before, so I remember the port. You can even say get board info, and it thinks that it's an Arduino Uno board like your robot kit. And if everything is working and it's reading the libraries, I should be able to upload this to the board. Okay, well, needless to say, the examples that are in the website are not working because they were written for some old Arduino compilers. So we are I'm going to show you how to find the most recent examples. Besides the the Arduino project folder, which has a lot of examples in there, you can actually open the Arduino program. And since we installed the library already, we should be able to get some of the examples out of there. So to find the examples, go to Examples, under File, go to Ethernet 55, and these are the ones that will work in your board. Okay, so we can try the web server. Okay, we have the web server example. You can see that this one also has an IP address already in there, a MAC address. It's got the port number already in there. It'll give you on the serial monitor what the IP address is. And you can also have it display whatever you want out there. Right? Like you can have it say hello, for example. You can have it read an analog port. Okay, so this one is a good example to try, and let's give it a try. Okay, so it's compiling the sketch. Uploading. See that it's uploading. It's done uploading. And we can click on it, and we can see that the board, right? So this board is now responding. Right. So when I go here, it's actually responding. So I can even reset it, and it'll, as soon as it turns on, it tells me that the server is ready. So the next thing is to configure our local machine, because I plugged it into to here. So one goes to the Arduino board, the other one goes to my computer, my laptop. The other thing is to configure the laptop to be within the same range, right? The same IP address range as the web server, so that we can actually see the website. So we can right click on our network icon, open network, go to Ethernet, change adapter options, and right over here I have a whole bunch, but I would disable like my Wi-Fi and all those things, and I would this is my my Ethernet, it's a Realtek USB, and should be, yeah, if I right click on it, say status, details, it looks like it just has like a auto config IP address. So I'm going to right click properties. I'm going to put it in the same range as my little guy here, as my web server, so that it can talk to each other. So that would be 192.168.177. Okay, 192.168.1. 1 dot let's see, this one was 177, so I'll just say this one is 199. Okay, just this is all you really need, I believe, to communicate with it, because there's no other configuration. So 199.167, it says unidentified network, status, detail. Let's see, let's open up our PowerShell. Let's do an IP config, see where we're at with this. Okay, so that's my VirtualBox, my Ethernet, but my real Ethernet adapter has that. Ethernet 4, that's the VirtualBox, so don't worry about that one. Okay, let's see if we can ping. See if we can ping our 177. we may have to be, oh, it looks like it talks to it. Okay, so if I can talk to it, that means I am talking to my board here. So let's go to the website here locally. 192.168.1.167. Oh, 177. Okay, 177. Oh, there we go. Perfect. So now we have our web server embedded in our little board here. Okay. And I just went to the website in there. And it says analog input equals, for 0 port 0 equals 169. Right? You can actually kind of mess with the numbers by touching some of those pins. But so this gives you an idea. Let's go over the code a little bit more. I like to work with at least 18 points so I can actually see it better. Okay, so I'm using the libraries. I gave it an IP address. I'm using port 80, which is what the web server uses. Okay, and I'm just saying that the output to the serial port, hey, the server is located at this IP address, and it'll tell me. Okay, and it's got these functions which are built in as part of the, these are all part of the libraries. And let's see. Okay, this is all part of the whole HTTP web page, right? This is creating a website. So if you look over here and say, let's see, I believe it's F12. So F12 gives you what the website looks like. This is all the website is, right? This is the top part, and each one of those. This is all what the web page is. The HTML code for it. Okay. But you can also say Alt F. Let's see. You can also do this. Let's go back and remove F12. You can say View Page Source Code. And it's right here. This is all the HTML page that is created by this guy over here. Is okay. So right. Let's see. Okay. So that just kind of gives you an idea on how to read specific channels. There are other examples. Okay, if we look at the code here on the instructions, by the way, we have to do the same thing with the Wi-Fi module. It works the same way, except that when we configure the network, we'll be dealing with a Wi-Fi address, so that we can connect to the board via Wi-Fi instead of having all these wires. We'll connect with our laptop to our Wi-Fi module. All right, so this kind of gives you a little bit of how to browse to everything we just did right now. Understanding the code, this tells you everything that I just told you right now. But I do have some other neat examples here. For example, don't worry about that. For example, I have this next example here on how to output to a digital pin. Okay, so this example will just output to a very specific pin number. So now that we have the user interface needed to turn on and off something, we can create a button where we can actually, because what happens is with this one, the web page runs as soon as you call it, and it runs the code right away. There's no buttons in here. So you'll need to figure out how to create buttons on your website. Okay. So I gave you this example here. It's a quick one. Web server with button to turn speaker on and off, and it shows you how to create a button. Okay. So that will fulfill part of it. So you would just try this source code here. You have to make sure that you plug in the pins in the right place, right? So you have to plug in your speaker on pin number 8 because it's an output pin. And as soon as you run the website, there should be a button that appears on the web page that should allow you to turn the sound on and off. And that should be enough to fulfill part of what's required. Okay. The rest of it you're gonna have to figure out pretty much on your own. But I'm giving you the example of how to kind of make this one work. You'll still have to figure it out. But I'm also giving you let's see. This is optional, how to create a chat server where you'll be able to talk back and forth between your computer and the Arduino via the internet, via an IP address using a telnet. Telnet is a way to connect to a terminal, and I'll explain later on in the lecture, but it's a really cool little example that I like a lot. And in one computer, you're typing something on the telnet prompt, and on the Arduino, you see it, and then you can type something on the Arduino and send it back to the other computer. So it's a chat program. You could be across the world and chat with somebody via this interface here. Just really neat. I like it. Kind of shows you how to connect a motor, right? How to connect a servo motor, how to move the motor, but it doesn't show you how to move it on the website. You have to figure out how to. You're going to be an integrator here, okay? And you should, if you took some of the other classes, you should be able to know how to move a motor, how to turn an LED on via a microcontroller. Okay. All right. So I hope this gives you enough information. I'm going to do a little video clip to show you a little example how to do it with the Wi-Fi card. It's the same thing, by the way. The trick about all of these things is on the Arduino interface, when you download a library for a particular product, it usually comes with a lot of examples. So if I was you, I would explore here a couple of things. I would explore the original Ethernet, for example. Okay, but the one that we have is the Ethernet 55. There's a chat server example there, right? So I would explore that. And let's see. I would also look online. There's a ton of other libraries that people have created for these products, and you should be able to get the data. So right here, for example, you can do this one, standard Fermata Ethernet. This one right here is another example that you can load. Okay, and what you can do with this one is you can do a lot of input and outputs. Okay, and it works very well with the Arduino Uno, which is the board that we're using basically. And so with this one, you should be able to read and write to the ports. Okay, so for example, this one will scan all the ports to see what you have connected there. And so you can explore this particular one. I experimented with it before. It's really good. Let's upload it, make sure that it actually will upload to the board. If it uploads, then you can start playing with it. Okay, but this is what people use to begin with. They use this example. They use the Ethernet example as well. Actually, this one is part of this file. They use that other one, that other example on their Ethernet 55. Okay, but you can also just do a Google search. Just do a Google search and you'll find a ton of other examples on how to do it. Okay. All right, let's see. Did it upload? Yes. So yeah, so you should be able to use this one also to scan and to do whatever you want with the ports. Okay, so this one is working pretty good. All right, it's a generic protocol for communicating with the microcontroller. All right, so I'll show you real quick later on how to do the Wi-Fi, so stay tuned for that one. Before I go into the details of using the Wi-Fi card that we have, the Arduino Wi-Fi card, I wanted to give you one example at least on how to connect the Ethernet card. Okay, so what I have here is I have an Ethernet card and I have just one LED connected to pin number 8. So it's connected to pin number 8, and I have my board connected to Ethernet. So I have my laptop on one port, okay, my laptop on one port, and then the Ethernet card on this other port. Okay, so my laptop and the Arduino, and I have them both on the same network. So the first thing you want to do is you want to come over here to your network settings, open network, go to Ethernet, go to change adapter options, and you want to disable everything else that you have except your local Ethernet card. Right click on it and click on properties and get rid of the IP version 6 just in case, but let's configure IP4, and I put it on the 192.168.1.199. That's my local computer IP address. The important thing to remember is to put them in this network range, and you can use this subnet mask. So it's in the 192.168.1 and whatever host number. Okay, so now that we got that, let's put the Arduino, let's put this guy on the same network so that via the hub here, it can talk to this switch. Okay, so I got this example, and you can open it on the projects folder. You can just go to the ET497 folder that you will get in your memory stick, and it's under projects. This is project number 5, and there's an example there for LED on and off. Okay, so open up that LED sample Ethernet, and again, the pin is attached, the LED is attached to pin number 8, and this one is a simple web server that has a button on the web page to turn an LED on and off. We have a MAC address, we have the make sure that we have these libraries, which this ones come with Arduino, but you probably already installed the libraries that I showed you earlier. I give it an IP address of the same range, the 192.168.1, except that my Ethernet shield, this guy, is now going to be number 20. Okay, and then the same subnet. So by doing this, I'm able to talk to my laptop over the switch, and I put it on port 80, which is a standard port. I have my LED on pin number 8. Okay, LED is pinned as an output, and you can also have something go out to the serial port in case you want to see some statuses. Okay, this is more status. This is reading the string, so we're going to read our input, and depending on the input, it'll go to a specific function over here. So like for example over here, if read string index of light on is greater than 0, right, checks for me clicking the button on switch on the web page. This is creating a web page, right? This is a web server creating a web page. and I wanted to put two buttons, one to turn the LED on, one to turn the LED off. Okay, and that's it. We're just reading that string, and depending on the string, it writes it back to the Arduino board. Okay, so this is pretty neat. You might want to take a look at a few other things. There's a little area where you can clear the strings as well, right? So check out the whole code here. All right, so let's open it up and let's look at some of these things here. I'm just going to open my web browser, and remember my IP address was 192.168.1.20, and there you go. Home automation, turn on light, turn off light. Right, this is my on my web page here. If you look at the start of the web page, okay, starts over here. And you can see that I have a title, right? And the title is Home Automation. Could have called it whatever I wanted. And we also have our heading. So this is the title of the web page. This is the heading. So if you look at the web page, right, this is the title. This is the heading. Okay, similar to like the web page we updated in the Linux environment. All right, so I have my two buttons here, my turn on light and turn off light. So if you look at let's put them side by side if possible. Okay, if you look at the it's a little bigger. If I say turn on light, it should turn on the light on pin number 8. Okay. If I want to turn it off, click turn off. And that's about it. So that gets you started. Now you can go ahead and figure out how to add switches, how to add how to turn on a sound. That should be very simple. This one will get you started on how to turn the sound on and off. Also how to turn the servo. This one will help you. The how to receive a signal from an external physical switch, that's going to require a little bit more thinking, but you can still use the exact same example here. Let me open up the serial monitor so you can kind of see some of the values that I'm putting out over here. So I'm putting out the server IP address and the LED controller, which is the title of the program. All right, so have some fun with it. This is a pretty exciting time to be alive. Look at all the cool things that we can do with this thing. All right, so we'll move on and we'll talk about how to do these things wirelessly, right? And we'll get rid of this guy, we'll get rid of this connectors, and we'll configure the laptop to talk to this. All right. So we're going to learn how to install the driver for the our little Arduino D1 with a nice Wi-Fi module here. And so let's check this out. So I have an LED right now connected on pin number 2, so pin D2 of the board. And of course the board comes with a whole bunch of little parts. You know, you have your speaker and all that. So you'll be able to do all the labs that are related to the Wi-Fi, just like you did the ones with the wire Ethernet. Okay. All right, so let's do this. We have the instructions here. A little bit about this board. This board has a different USB driver. This one has the CH430 USB. All the Arduino Unos, the original ones and some of the older ones, they come with a USB driver that you do not need to install a driver in a Windows 10 machine. But in order to reduce cost, they added this chip over here for communication via the USB port. It's a cheaper chip, and to save cost, they added that in there. The problem is that now we have to get a driver for it that we have to download. You can find the driver on the memory stick. So let's install that first. So I'll go to the folder where we have our memory card in there, and it would be the D1 Arduino Wi-Fi. Here's the CH341 driver. Go inside there, double click it, click yes, installs. And so this should install that CH340. Oh, driver failure. I think I already have the driver installed from a previous install. So let me see if I see the board once I plug it in. Alright, so the first thing is install the driver. The next thing is we have to install the board. Okay. Now the board has all the same I/O pins as a regular Arduino Uno, and it's got an Arduino chip in there, in here, but it also has a Wi-Fi chip in there, an antenna and everything else. So it's called the ESP8266, and this is the -12 model. It's a really powerful CPU. It's 32-bit CPU, 32-bit CPU. It does have 802.11b GNN. It's got the integrated TCP/IP protocol stack, just like the Uno, a 10-bit ADC, right, analog to digital. It does support some other security features like WPA, WPA2, and a whole bunch of other things that are really neat. The other thing is it does have an 80 megahertz processor, so that 32-bit processor is 80 megahertz with 4 megabytes of flash, and of course a micro USB programming, and it supports anywhere between about 5 volts to 12 volts in there. 6.5 volts they say, but 5 volts will do it too. Alright, so the first thing we have to do is we have to download the boards to the board manager in Arduino. So once you install your Arduino code, go ahead and copy this. You install your Arduino IDE, your programming interface. Okay, open Arduino and go to File and go to Preferences, and where it says Additional Board Manager, go ahead and paste that in there. Control V. There we go. So Control V, click OK. Okay, so now we're gonna go into, let's see, we're going to our boards manager, and that would be under boards, board manager, and just type ESP to see if you find that 8266. There it is, ESP8266, and this one is the latest version, 2.72. Just click install, and it's going out to the internet, and it's downloading the definitions, and that includes examples and things like that for this board. It supports a whole bunch of Wi-Fi boards that are out there, from the SparkFun Blink to the 8285. There's so many of them out there. So we should be able to do the same thing that we did with the other board, with the wired Ethernet board. We should be able to do the exact same thing with this board. So once looks like it's completed already, click close, and we're going to go to the boards, and we'll scroll down over here, and we're going to select the generic ESP8266 module. Okay, and then we'll be able to also check out any examples that came with it. So if you go here to File, Examples, you will see that now you have a whole bunch of examples for the 8266, including our web server example, which is the one that is required for your lab. So we'll also be exploring those and see how those works. There's a whole bunch in here, so this is really neat. A lot of cool examples here. Okay, so now let's download a program over here to the D1. We have a program here, a little blinking LED program, and what this program does is as using the library, right? The ESP8266 Wi-Fi library. But what the program does is it'll flash the LED connected to GPIO2. GPIO2 is a built-in LED into the little board. It's actually connected, GPIO2 is actually connected to this board over here. Okay, but what that means is it's also connected to a built-in LED on the main ports, and that would be pin number D9. Okay, so pin D9 on the main board, right? So I'll call it the main board. Okay, so that means that if I plug in an LED to pin 9, it's the same thing as flashing the LED that's in here. Okay, so I'll connect over here to pin number 9. And so what we're going to be doing is checking a few settings over here. First of all, we can look at what we need to select over here. Make sure that we have the generic board. Second, and most importantly, is that we have the right communication port. Okay, so this is communication port number 9, so make sure that you select that port. Okay, and so now we can just upload it, and we can wait a little bit for it to upload. So it says uploading. It gives you some status updates over here. We're at 16%, 33%, and we can see that when it finalizes uploading, we got at 66. Okay, and we should be looking at the board now, and so it finished uploading, and you can see that it's flashing. Okay, so the built-in GPIO LED on pin number 2 here of the little Wi-Fi board is the same thing as the pin number 9 over here of the I/O board, and it's located in our document here. It's the built-in LED connected to pin number 9. It's the same thing as the GPIO2 of this board over here. And so that's how we can flash the board and do a little bit of a blinking LED connection. Okay, so I'm hoping to give you now some examples on how to connect this to the Wi-Fi, and how to connect the web server and try to do our turning on and off an LED on our website to get you started. Okay, I got to show you a few more examples, because everything that's over here on the examples, there's a ton of good stuff. So let's give you a couple of little things here. Look at the blink example that came with it, right? So let's look at blink. Okay, it's the same thing as we did in the previous example. This is going to blink the built-in LED, okay, that's in the module, and there's a function that came with Arduino. It's called LED built-in, and so that automatically looks at the built-in LED. By the way, did you know that you can come over here and you can look at the built-in LED, and you can decide what port the built-in LED is on. So remember in our last example, it was port number 2, right? So we put it as port number 2 because that's where it is in this particular board. But we have our little board there, and we're going to flash it with this example for blinking LED. So it's going to compile. It'll give us an update of what's happening over here. So we're at 50% right now. Okay, let's check it out. And there you go, finish flashing it. So now you have both LEDs, right? The ones that are connected to the pin number 2 there of built-in LED. All right, so that was pretty neat. So let's look at some other examples. There is another example in here, and this one is also under examples 8266, and let's see. We have the one that I want to show you. Where was it? I was just looking. Oh yeah, it's under HTTP. Well, HTTP is the ESP8266 Wi-Fi. There's one called Wi-Fi scan. So check that one out. So we have this Wi-Fi scan. This demonstrates how to scan any Wi-Fi networks that are on your wireless network. So let's check that out. And so our little board here, that little module, the Wi-Fi module, is going to go out there and scan for Wi-Fi networks that we have around our place. So go ahead and flash it. Remember that the speed for this particular board is 115. So when you look here, make sure that you select 115 for the upload speed. It's also the speed for your serial COM port for this one right here, serial monitor. Alright, so it's still uploading. Okay, so this is using that library, and thanks to that library, it's going to start doing a little bit of a scan. It puts the module into a scanning mode, and what it does is it scans the networks, and then it should show you here under the print screen, the print line. If it finds a network, it'll show you what it is. So done uploading. Let's open up our serial monitor. Okay, and you can see that it did scan, and it found two networks. So it found my home network, which is that Robot 2.4G. Okay, and it keeps doing it automatically. And it found this other network that I don't know what that is. All right, so it's really neat, right? Shows you a little bit of everything that's going on. So you can do all kinds of crazy things. So let's see if we can look at another example here. Okay, and now for the demonstration that's going to help you to finish the assignment here, the lab. We're going to blink the LEDs via a web page wirelessly. So we're going to connect with the laptop wirelessly to this chip here via Wi-Fi, and we're going to blink or turn the LED on and off based on a link that we press. And so first of all, what we need to do is we need to get your example. So the example is under File, Examples, and it would be under the 8266 Wi-Fi, and it's called the Wi-Fi Manual Server. Okay, so you open it up, and right here it tells you this sketch demonstrates how to set up a simple HTTP-like server. This server will set up a GPIO pin depending on the request, and the GPIO pin that we're using is our built-in LED, right, which is the one that we have been using for the other examples. So we know that it's connected correctly already. So the one thing we first have to do is type in our SSID for our Wi-Fi network, and to find that out, I come over here and I see that mine is Robot 2.4G. Okay, so Robot 2.4G, whatever your SSID for your network is, that's what you put in. You can find that over here, down here. And then whatever your password is for your Wi-Fi network. Okay, so I am just entering whatever my Wi-Fi password that came with my router is, and that's it. This thing is going to connect at 115,000 baud per bits per second. baud rate, the port 80 for our server, and it's going to spit out the data under the serial monitor so you can kind of see what the web server IP address is. So it's going to grab an IP address out of your router, your home router. It's going to give it an IP address in the same range as your laptop is, and it's going to assign it an IP address to our little module here automatically. Okay. Then it'll tell us whether it's connected or not, whether the server started. It'll return an IP address. It'll return an IP address for you, and then based on that IP address, we can go ahead and find out what that IP address is, and then we can do a digital write via a request that we click on. Okay. If it's invalid, it'll tell you that it's invalid. Okay, so it gives you, these are the href, which are the links, the HTTP links to the local IP address. Okay, and it goes to a specific GPIO, whether it's GPIO 1 or 0 to turn it on and off. Okay, and so let's do that. Go ahead and upload it. So this is compiling the sketch. We can get some of the statuses down here. Okay, so our little guy here is being flashed right now. We are at 69% right now. Okay, 100%. Done uploading. It's doing a little reset on the real-time system of the reset pin of the board. So go ahead and click serial monitor. Okay, if you don't see anything coming up, go ahead and reset the board. The board has a reset button on the corner over here. Go ahead and press that and look at the COM port here. Okay, so it says connecting to robot 2.4G. Wi-Fi connected, so I'm connected to the router, to my 2.4G router, and it gave me an IP address of 192.168.1.108. Okay, so all I have to do is open our web browser and start typing that IP address. So 192, let me just put it over here, 192.168.1.108, 108, enter. So it looks like I have a website. I'll put this guys over here so you can see what's going on. Let me move this up a little bit more. Let's see, right about there. Okay, and so I'm looking at what's happening, and so what I can do here is I can say click here to switch the LED on. So I click here and you see the LED turns on, and it tells you what it's doing over here. I click here to turn the LED GPIO off. Okay, it turns it off. Right, so on, off, on, or off. Okay, so your job is to create a website like this that in that code that will automatically turn beep sound on our little speaker. Okay, maybe turn different colors of this multicolor LED if you want. Have a switch that when you press it, it does something, right? So play around with it. You got plenty of tools. But this is neat, right? We have our website that when we click on it remotely, so from anywhere in the world, we can turn this LED on or off. Okay, and we got a little bit of a feedback here of what's going on. All right, well, have fun with this. That's about it.